Okay, so you've learned about work in this unit, and now I'm going to teach you about something called impulse, which as far as the way it works is very similar to work. So impulse is a force acting for a period of time. Work is a force acting over a distance. So one of the more recent discoveries in physics is that time and space behave very similarly. So you think about, like on a coordinate plane, you've got, I should be drawing this, that would make more sense. On a coordinate plane, you've got like a x and y axis. Imagine then if you made another axis, so kind of imagine this going back into the page, and you called that axis time. You can actually have things happen over time, and the units on time would be what you might expect: seconds, 2 seconds, 3 seconds. If you apply a force over one of these spatial dimensions, like distance, that force over distance is called work. If you apply a force over time, that force over time is called impulse. That was a big explanation just to kind of give you an idea of modern physics. The important takeaway is a force acting over a time is called impulse. And in your head, I think you should make a connection to a force acting over a distance is work, because it's both a force, one acts over time, one acts over distance. All right. We can calculate impulse. Impulse is force times time, just like work is force times distance. Very similar things. Force has the unit newtons, time has the unit seconds, and impulse has the unit Newton seconds. More commonly written, don't know why I did the dash there, Newton seconds, Newton's time seconds. Force was Newton meters, work was Newton meters, impulse is Newton seconds. The way this works is if you have an object, say this dummy's head, and it has a color code here, it has a velocity forward. If you want to bring that dummy's head to rest, you have to apply a force opposite its velocity, because forces cause acceleration, and acceleration change in velocity. So I have to apply a force opposite the dummy's head. If I don't want to hurt the dummy, what I can do is apply a very low force over a long time. So impulse is your stopping or accelerating ability, you could think of it that way. I can have a big time and a small force and get the same impulse, so my motion can change just as much. So if I don't want to crack open the dummy's skull, I can have it take a long time to stop and give it a very small force. This is like the question about the egg. When the egg hits the wall, it takes a very short time to stop, and so a very big force. Small t requires big F to give the same impulse. When we throw the egg against the bed sheet, it takes a longer time to stop and requires a smaller force. As we go through this unit, we'll start to talk about momentum, which is basically something's movement described by its mass and its velocity. Impulse is how much a thing's momentum changes, just like work is how much a thing's energy changes. And so I'm trying to avoid using the word impulse when describing avoid using momentum when describing impulse. But right now, you could think of impulse as like your ability to stop something moving or start it moving. And if we want to stop something moving with a very small force, like on the dummy's head, because we don't want to hurt the person in the car, we need a big time to make that thing stop moving. There's a lot of info. Let me give you the summary. Impulse is force times time. If you want to stop something and not hurt it, you give it a small force, a big time. If you want to stop something quickly, you can give it a big force and a small time if you're not worried about hurting it. Both a big force and small time, or small force and big time, can supply the same impulse, which right now you can think of as like stopping power. In this equation, force has the unit newtons, time has the unit seconds, impulse has the unit Newton seconds. Key takeaways. Moving on. So here's a fairly simple example of using impulse. A 2,000 kilogram car starts from rest at a red light. The driver holds, should say an S, down the gas pedal for 10 seconds, applying an average force of 375 newtons. What is the impulse on the car? Okay, impulse is force times time. Impulse equals force, 375 newtons, times time, 10 seconds. Impulse equals 3,750 Newton seconds. And that's how you use the impulse equation. Very simple, very straightforward. But as I'm sure you know, just like work looked simple, you can get some doozy questions out of it. So, make sure you understand all that. Hopefully the questions work in the video to let you know what was important. If not, you still got to watch the video. I highlighted the important parts. Next, we're going to talk about force time graphs, which are related to impulse.